Modern industrial and power electronic systems are becoming faster, more compact, and increasingly electrified than ever. But how do you transmit high-speed digital signals across high-voltage barriers safely and without degradation? In this tech guide, we'll explore how Diodes Incorporated API772X dual-channel digital isolators solve that challenge. From core design features to implementation strategies and real-world applications, this tech guide breaks down everything you need to confidently integrate these isolators into next-generation systems. Let's check it out.
Step 1. High isolation for safe signal transmission.
As digital systems accelerate and power stages operate at higher voltages, transmitting high-speed signals across hazardous boundaries becomes a major design challenge. The API772X isolators combine robust 5,000 volts root mean square isolation with high-speed signal fidelity. That helps enable safe and reliable communication across high-voltage barriers. The API772X series achieves this with up to 8,000 volts peak withstand capability, supporting reinforced or basic isolation in demanding applications. Certified to UL 1577, VDE, and CQC standards, these devices provide the documented safety approvals required for industrial, energy, and telecom systems. At the same time, their architecture preserves signal integrity, helping to ensure high-speed data moves cleanly across the barrier. So with the API772X, engineers gain high-speed isolation they can trust, both electrically and over the long term. Next, we'll cover high-speed performance without isolation slowing you down.
Step 2. High-speed performance.
As control system speeds increase, isolation must keep pace. By delivering up to 100 megabits per second throughput with just 11 nanoseconds typical propagation delay, the API772X keeps signals moving quickly while maintaining tight system timing across the isolation barrier. Operating at high speed with CMOS threshold inputs, the device preserves precise logic integrity for demanding applications like motor drives, solar inverters, and industrial automation systems. The result is high-speed isolation that helps protect your system without compromising performance. Next, we'll examine the factors that threaten signal integrity and how to overcome them.
Step 3. Robust common mode transient immunity.
In high-power systems, fast-switching edges can generate intense common mode transients that threaten signal integrity. With a plus or minus 150 kilovolts per microsecond minimum common mode transient immunity rating, the API772X maintains clean digital communication even during rapid voltage swings. This common mode transient immunity ensures reliable operations in electrically noisy environments such as industrial drives and renewable energy systems, where switching events are frequent and aggressive. This is a major advantage, delivering isolation that remains steadfast, even in challenging electrical environments. Next up, how do you make sure isolation works efficiently right from startup?
Step 4. Flexible logic and low power.
In space-constrained and power-sensitive systems, isolation must be efficient and predictable at startup. By offering selectable default output logic and drawing just 2.1 milliamps per channel at 1 megabit per second, the API772X delivers both fail-safe flexibility and ultra-low power operation. Designers can choose default high or default low configurations to match system startup behavior and safety requirements, while keeping thermal impact minimal in dense boards. Next, let's dive into how these devices hold up mechanically.
Step 5. Temperature and mechanical reliability.
Industrial environments don't just challenge your circuitry, they also challenge your packaging. By operating from negative 40 degrees Celsius to 125 degrees Celsius in a robust SO8 wide Type CJ package, the API772X maintains isolation integrity and performance even in harsh conditions. Its compact footprint supports dense PCB layouts, while the lead-free, fully RoHS-compliant design helps ensure long-term durability and environmental compliance. So these isolators really deliver rugged performance, built to handle the toughest real-world industrial demands. Next up, we'll cover some practical integration tips.
Step 6. Best practice integration tips.
Okay, let's go over some integration tips to maximize the performance of the API772X isolators. First, designers should carefully route signals to minimize noise and crosstalk while maintaining proper creepage and clearance distances to help ensure safety across high voltage barriers. Next, the PCB layout should be optimized for low noise operation, with isolator channels aligned to system logic and stable supply voltages provided to maintain reliable performances. These isolators can be paired with digital sensors, microcontrollers, or communication lines in applications such as motor drives, solar inverters, data centers, or grid equipment that will provide safe, high-speed signal paths across high voltage domains and help ensure both signal integrity and isolation reliability. Following these best practice tips will help ensure the API772X isolators provide reliable, high-speed isolation. So where can these isolators be put to work? We'll cover applications coming up.
Step 7. API772X Real-World Applications.
In applications where both speed and electrical isolation are essential, choosing the right digital isolator can make all the difference. The API772X excels in these kinds of environments. In solar inverters, it protects control electronics while maintaining high-speed signal monitoring. In motor controls, it safely isolates feedback and command signals across power stages. For industrial automation, it ensures reliable communication between PLCs, sensors, and actuators. In data center and telecom equipment, it enables high-speed signaling across isolated channels. And in grid and electricity meters, it provides robust high-voltage isolation for accurate metering and monitoring. Across all these scenarios, API772X digital isolators deliver fast, reliable, and safe signal transmission, safeguarding both systems and operators.
Conclusion.
As industrial and high-speed systems handle higher voltages and faster data, strong isolation has become essential. Diodes Incorporated API772X dual-channel digital isolators deliver high-speed, high-voltage isolation, low propagation delay, robust CMTI, and decades of reliable operation. For engineers designing next-generation systems that require safe, high-speed, and reliable digital isolation, API772X is a proven, versatile choice. To learn more or to purchase these isolators, visit Mouser.com or click the link below. And be sure to check out our other tech guides, because smart minds never stop learning.